Hi, this is Jim from Conveyor, and I'm going to show you how to create a Docker-based web application in VS Code, connect to it from the internet during development, which might be useful for webhooks or testing from other devices, and then deploy it to the cloud in Azure and AWS. Now, I already have Visual Studio Code and Docker Desktop installed on Windows. Docker Desktop is running in Linux mode. So to start, I'll create a directory for the project and create a .NET Razor template web project inside it. And then I can open that folder in this instance of code using code-r dot. Here you can see the files for the basic ASP.NET Web App template, and to create the required Docker files for it, I'm going to use the Docker extension that I installed earlier from the Extensions tab. So I press F1 and type docker add Docker files to workspace, then .NET ASP.NET Core, Linux for me as my Docker is running Linux containers at the moment. It will ask for the port, which I can get from properties launch settings.json, and it's in the SSL port setting, which is 44351. And no to include Docker compose files. If I debug it now, it will not run in Docker, but just run normally directly on the PC. So I'm going to go to the debugging tab and change the drop down to docker.net launch, and then run and debug, and it will launch the application inside the container. The browser opens automatically with the URL set to use a port number that maps to Docker's internal port for the web application. But note that the port that is used in the browser is not static, so it will change from time to time, like when you close down the container and reopen it. And this is inconvenient, so let's fix it. To prevent it changing ports every time we restart the app, I will open VS Code tasks.json and look for type docker run, label docker run debug, and also docker run release. This is where I will add this block that I copy and paste instead of the empty docker run. And then again for the release section. The container port is the port number that the application is running under inside the container. So I can get that from launch settings.json under IIS settings, IIS Express SSL port. I'll paste it back in tasks.json. And the host port is the port that I want to use to connect to the app on my host. Here it is 8080. Now I can run and debug the application and see it working with my browser, which is connecting on port 8080. Okay, so now I have an ASP.NET Core web app that is running inside Docker. That's great, but let's say we want to connect to it from the internet. We might want to do that because we want to work with webhooks, or we need to easily access it from other devices for testing, or we want to share the current build with someone remotely. I'm going to install our free tool Conveyor to do that. First I go to https conveyor.cloud in my browser, and then click Install the command line tool. I'm going to follow the Windows instructions, but there are separate instructions for Linux too. I already have .NET 7 installed, so I will only need to download Conveyor. Open a new terminal by splitting this one. Make a folder for it. Change directory into that folder and download the executable. For simplicity, we distribute the executable directly instead of an installer. That means that you can run it from the command prompt when you're in that folder only, unless you add the folder path to your system path variable. For brevity, I won't do that. If you want to do that, just use the system environment variables control panel. If we run Conveyor now, it will only open access to the local network, which can be useful if you're using IIS Express, for example. However, in order to use Conveyor's internet tunneling, we need to quickly register for an account, which can be done with this command, Conveyor CLI config-r, to open the account register page in the browser. Once registered, you can run Conveyor CLI config-s to store account credentials, and finally run Conveyor CLI-p 8080i, where port 8080 was specified as the host port for the application in tasks.json. Also, because the host port is running HTTP and not HTTPS, I specify the I for insecure after the port to signify that Conveyor should connect to it using HTTP rather than HTTPS. Conveyor is running now, but I just need to make sure I'm debugging the project, or else there'll be nothing to connect to, so I'll launch the debugger. Now that it is connected, I have an internet accessible URL which I can launch by pressing D in the Conveyor terminal window. I can now connect to my debugging application from any internet connected device, including webhook services, which can be useful for receiving notifications from the web. Okay, so now I can develop the application like usual, adding features and testing them over the internet if need be. When I'm done, I will want to deploy the container image to a production server on the cloud. How can I do that? I need to stop and clarify some terms here. Firstly, when we say image, we mean the files and parameters that actually hold your application and the file system it is built upon. Secondly, container means the actual running instance of an image. So the first step is to build the image. So press F1 and type docker images build image. When that has finished, we can push the container image to a Docker registry. There are different options for registries, including private registries, and Azure has a registry, but a simple and free way to do it is with Docker Hub. Once the image is in a registry, it is easy to have the cloud service pull the image and make a running container. I've already signed up for an account at hub.docker.com. Here you can see my empty Docker Hub account. Now, back in VS Code, in the Registries tab under Docker Extension, I can click Connect Registry and choose Docker Hub. My Docker ID is my account name, which is Quixote. And then it asks for my password or an access token. You can use your password or go back to the Docker Hub site and generate an access token by clicking your account in the top right, account settings, and then in security we can create a new access token. So I'm going to copy that, go back to VS Code and paste it in here. This is more secure than using your password because it has less access than your full account credentials, but should still be kept private. We need the token here, and would also later during cloud deployment if we use a private repository. Now that the extension is linked to my account, I can update registries. I want to push my container image to Docker Hub, so I go to Images and expand Demo Project. And right click on Latest and select Push. And I'm pushing to my namespace. And that tag is fine. So I'm going to want to deploy it on Azure and AWS. Azure has a free SKU for web app container deployment, but I'm not going to use that now. The reason is kind of complicated. Essentially, the free level web app container gives you 60 CPU minutes per month at the moment, which is fine, but configuring it to work with a port other than the default 80 or 443 seems to be impossible in the portal. There is a property named Websites Port where you should be able to configure a custom port, but it doesn't appear to work from what I've seen on the net. You can make your container use port 80 instead of the higher port numbers you get by default, but that requires changes to the Docker file to give the user process elevated permission, which you certainly can do if desired. But Azure has two other types of container hosting. There is Container Instance, which is quite low level and will host a web application, making it available for connections on the internal ports specified in the application, for example 44351 in this case. However, to map it to a standard web port like 443 is much more involved, as it requires creating a load balancer and the networking components that go with that, such as a virtual network, subnets, security groups, etc. It's doable, and there is a how-to linked in the description. The other type is Container App, which I will use. It is nice because it automatically maps port 443 to the internal port used by the container image. So I'm going to set up a Container App now with the Azure subscription I already have set up. So this is portal.azure.com, and now I'm going to click Create a Resource. On the left there is Containers, and then Container App Create. The defaults are fine, I just need to give it a name. So Demo Project, and then I'll click Next, and we don't want to use a quick start image. We want to use Docker Hub, and I'm going to need to use the image and tag. To get that, I go back to VS Code, and if I refresh registries, we can actually see now where the container was pushed to. So I expand it all the way down to the tag, right click, copy full tag, go back to Azure, and paste the tag name there. Okay, and next to ingress, enable it, and accepting traffic from anywhere. The type is HTTP, and that setting is what maps the standard ports to the container port for us. The container port is entered down here in target port, which was 44351. Review and create, and then when it's ready we'll click create. Wait for it to deploy, and then it'll give us the application URL, which I can click and see my application running. There we go, click Go to Resource, and here is the application URL, which we can click, And there's the application on the internet. Great. And let's do it again with AWS now. So I've signed into the AWS console, and I'm going to type ECS into the search bar, Elastic Container Service. First of all, I need to click clusters, and I'm going to create a cluster. I'm going to call it demo cluster. I don't need to change the VPC. That's the virtual private cloud. So that's all fine. Click create. A cluster in AWS is a logical group of tasks or services. And so to run a container image, what I need is a task which will define the container image to run, amongst other things. So create a task by clicking Task Definitions, and then create new task definition. I'm going to give it a name, Demo Task, and name the container. The URI is obtained from VS Code. You can copy full tag from the tag in the registry. But with AWS, unlike Azure, you have to specify the host name first, docker.io. And as we remember from earlier, the port number is 44351. And that's all we need there. This is all fine. So create. Okay, now we go back to clusters. So what we have is a task definition, but to actually create the task, we need a service that will do that. So we go back to the cluster, click create down here under services, and then we're not interested in the capacity provider strategy, that's fine. We need to choose our task that we just defined and give it the service a name. And then we're going to expand networking. It's the same virtual private cloud as before. We're going to create a new security group. Let's call it Demo SG. And I need a rule for HTTP traffic. This is going to be used for the load balancer, which is going to listen on port 80 in a minute. It's from anywhere. And we also need a rule for custom TCP ports. And this is 44351, the containers port. That allows the load balancer to connect to it. And then we'll go down here into load balancing. We're going to create an application load balancer. Give it a name. And it is automatically set up to listen on port 80. Just need a target group name. The target group is the group of containers that the load balancer can work with. Click create. Now this can be pretty slow. We'll just wait for it to finish. Okay, and it's done. So now we can find the load balancer that we created and then visit its URL. So in the search type load balancer, well, we need the EC2 one, not the light sail one. Select it. And then up here you can see the DNS name for the load balancer. So we'll just copy that, put it in a new tab, and remember that it's listening on port 80. So there we go. It loaded the application running inside the container. Thank you for watching this video. I hope it's been helpful. Please leave a comment if you have any thoughts. And of course, you're welcome to subscribe and like the video. Bye now.